we are going on with our revision of quadratic number patterns. So this is a problem-solving type question, and it reads as follows. Consider the pattern that emerges when you add the terms of a linear number pattern. And we are given the linear number pattern of 3, 7, 11, and 15. And we are also given the sum of each term in the pattern. So line 1 is term 1. Line 2 is the sum of term 1 and term 2. That is equal to 10. Line 3 is the sum of the first 3 terms. And line 4 is the sum of the first 4 terms. So let us look at the questions based on this information. So they want us to continue the next 2 lines. But in order for us to continue, we need the next 2 terms. So if we complete this pattern, we can see from 3 to 7, we add 4. From 7 to 11, we add 4. And from 11 to 15, we add 4. So this type of number pattern is a linear number pattern because there's a constant difference between terms. So the next term would be 15 plus 4, which is 19. And the term after that, 19 plus 4, which is 23. So line 5 would be 3 plus 7 plus 11 plus 15 plus 19, which is equal to 55. And line 6 would be equal to 3 plus 7 plus 11 plus 15 plus 19 plus 23, which is equal to 78. Now it's important to just follow the questions. Do not try and force an arithmetic series, and do not try and force a geometric series. So don't force to use the SN formula. That is not what they're asking us to do. They're simply asking us to find the sum of line 5 and 6. So don't overcomplicate your answer. Just follow the pattern and complete the next 2 lines. The next question is, what type of number pattern is formed by the sum of the number patterns in each line? So they're not concerned about this number pattern. We know that that is linear. They want us to create a number pattern with the sum of each line. So if I consider 3, 10, 21, 36, 55, and 78, let's see what type of number pattern this is. So from 3 to 10, we added 7. From 10 to 21, we added 11. 21 to 36, we added 15. 36 to 55, we added 19. And 55 to 78, we added 23. Now there's no constant difference between terms, so this is not a linear number pattern. So let us look at the second difference of terms. So from 7 to 11, we added 4. 11 to 15 is 4. 15 to 19, 4. And 19 to 23 is also 4. And now because our second differences are a constant value of 4, we know that this is a quadratic number pattern. And our third question is, determine the sum of numbers in line n. So they want us to continue this pattern up until line n. But we cannot continue just adding terms indefinitely, not knowing what the value of n is or where this pattern ends. What we need to do is use this quadratic number pattern, which we have identified in the previous question, to help us find a formula for n. So we will solve the quadratic number pattern, or the general term for the quadratic number pattern. So this might be confusing, because normally when we say find the sum of a number pattern, we think Sn. But there is no Sn formula that we can use to find the sum of these terms. So this is another way of asking us to find the general term. So we know that 4 is equals to 2a, that 7 is equals to 3a plus b, and that 3 is equals to a plus b plus c. So if I solve the value of a, so 2a is equals to 4, therefore a is equals to 2. I'm dividing by 2 everywhere. And I have 3a plus b is equals to 7. But the a value is equals to 2, therefore I can solve b by substituting a. So b is equals to 1, because we have 6. I move that 6 over, so it's 7 minus 6, which is equals to 1. And then a plus b plus c is equals to 3. But the a value is equals to 2, the b value is equals to 1, and we don't know the c value yet. So 2 plus 1 is equals to 3, and I move that 3 to the right hand side. Therefore c is equals to 3 minus 3, which is 0. Therefore the answer to this question is Tn is equals to an squared plus bn plus c, where a is equals to 2, b is equals to 1, and c doesn't have a value. So we can say Tn is equals to Tn squared plus n.